Peter here to fill in a little bit of narration where we don't have video. So once we got the bottom tape drive to mark tapes successfully, we ran the tape data test on the bottom drive in case the top drive was actually returning bad data. Unfortunately, the bottom tape drive had the same issue that the top tape drive had before, so we were pretty sure that the issue wasn't with either drive. However, we realized that the top drive also hadn't been cleaned. So we decided, learning from history, to try to clean the top tape drive. So in this video we're going to show you that process and what came of it, and then barring any results there, we dug into the source code to try to figure out precisely what's going on. Alright, so given our success in cleaning the lower unit and having it magically return to life in many ways, we've decided that since we've only been testing the top unit for our data tests and we're having these weird errors, the first thing we should really do is probably clean all the grime and gunk and whatnot off of the top tape drive. So that's what Dawson's working on right now, and while he's working on that, I am in the next room over here. We've spread out into the ACM lounge, and I'm looking at the source code listing for that data tape exerciser. We're trying to figure out again, are we not calculating the checksum correctly? Are we not storing it correctly? You know, is there a flip-flop that's not working that we just aren't running into that often? Trying to, you know, chase this bug down, but maybe Dawson cleaning the tape drive will solve the problem for us, so stay tuned. Alright, we are back. Dawson has cleaned the top tape unit thoroughly, and we're going to try that tape data test again that we've had so much trouble with, and we'll see what happens. Same problem. Alright, well, it was worth a shot. So right now we're digging into the source code of the assembly to figure out exactly what the problem is. So stay tuned. Hi, Peter here. So while Dawson is over here working on the flip chip tester, I am looking at the tape diagnostic that we're having issues with, trying to really narrow in on what specifically is the error that's causing this to fail. So the way the tape diagnostic works is that it reads and writes some data to the tape drive. From the tape drive it goes into the tape accumulator, and from the accumulator it gets compared against a pre-computed value that's been stored into memory. And somewhere in there it's failing. So it's possible that the pre-computed value is incorrect. That seems unlikely, given that the machine runs correctly. I mean, it's possible that it's not being computed correctly, but you know, we'll look at that. But it's also possible that it's just not coming back from the tape drive the way that it's supposed to, which is kind of what we think is going on. So what's interesting about this program is that you can choose a couple different ways of executing, and as we've said before, it doesn't print any errors, it just directs you to a place in the source code. So I just want to show you kind of the basic operation of the program and what it's doing, and then show you what the source code looks like and what we're trying to figure things out. So if we go up here, you've seen us do this where we run the test and this is what the tape drive does. Okay, it just kind of bounces back and forth. Okay, that's what it's supposed to do. I had a different setting on, which is why it ran a little bit longer. Okay, and down here on the console we can see I'll clear the accumulator with IO reset, and then I'm going to start 20 to start the test right here. And when I do that, the tape's going to spin back and forth. And it's showing us the multiplier quotient. It's rotated the value from the tape drive into the multiplier quotient, and the accumulator is holding the pre-computed value. So obviously these two don't match, and so that's why there's an error. Now, when it fails, what you can do is figure out, well, where is it stuck? So we're in the memory address 1276. So if I go into the source code, so I've got my handy printout here. Sometimes it's nice just to have it printed out. So I'm looking for the listing 1276. Getting closer. It'd be easier if I had two hands, but such is life. Alright, so 1276. Again, here we've got 1276, and this has something to do with the memory field, so don't worry about that 0 bit there. So if we look at 1276, you see there's a halt. Okay, so it's telling us there's a halt because there's a test. So this is the test failure. So we failed, and we failed. It says rotate the bad checksum into the multiplier quotient register. Okay, so that's what RDR14 does, and that's why in the multiplier quotient, that top value, we've got the value there. That's the bad checksum coming from the tape accumulator. And then we load the calculated checksum into the AC register, and then so that's loading the calculated. So this is a 2 instruction thing here. We're loading from this memory address, which is checksum, putting it into the accumulator, and that's so we can, and then we halt. So I, as the operator, can see the calculated checksum, I'm sorry, the bad checksum and the multiplier quotient, and then the bad checksum in the AC. Alright, so that says this is in E2, so that means that test 2 is the test that failed. Okay, so if we flip back in the source code to the beginning of the program, we see here is test 2. Okay, so test 2 does a write, and then after the write operation, we put the tape accumulator into the accumulator. So there's a tape accumulator and like the main accumulator, and then we check to see if it's equal to that calculated checksum. If it is equal, then we're going to jump out of. I'm sorry. If it's not equal, we're going to jump to the error that we were just looking at. If it is equal to, then we're going to move on and go to the next test. Okay, so that's what's going on. So we know that we're failing this test with the checksum. Okay, and we, I'm just playing around with seeing. There's some other options where this writes a fixed pattern using the left and right switches to the tape. So if I could change this to like 707070. And do IO preset to clear the accumulator. Now if I run start 20 again, it fails again. We have 1276, so it's the same failure. But now our calculated checksum looks like, let's see, 1654. Am I doing that right? 1654. Let's clear this again, and we'll change the input again. We'll do all 7s. Okay. Now if we do this, clear the accumulator, and if we do this again, our checksum should be different. And in fact, it is different, right? Our checksum value is different because our input was different. But once again, we've stopped at 1276. So it doesn't really seem like giving a couple different fixed patterns. Once again, a different checksum 1276. Something's not right with what we're getting back from the tape accumulator, so that's why we're looking into that. I'll come back if there's more to talk about, but I'm going to stop the camera for now. We're getting the same behavior from both tape drives, where it's failing a test called the T2 test. So what's happening here is the program basically clears the state, creates a data block in an image area in memory, calculates a checksum for that image area, tries to write it to tape, see the result of that. That's TAC is the tape accumulator to the accumulator, and then we compare it to this calculated checksum that we have. And if the checksum doesn't match the tape accumulator value, then there's an error. And so we ran a bunch of different tests and we're all seeing the same failure, and the tape accumulator isn't really changing the way we would expect it to, based on different input into that image block. You can use different fixed patterns for input or have it use a pseudo-random random number generator, but the accumulator seems to always have similar data, tape accumulator rather. So right now we're investigating whether there's possibly an issue with the tape accumulator that's not working correctly, but the other possibility is perhaps that generating that checksum is wrong, and so it's maybe the tape is functioning correctly but the checksum generation is bad. So we're looking into these two potential issues, but it's time to go home. So that's what we're doing right now, and we'll see you tomorrow.